Alright, so here's where you guys get to participate now. And I'm going to tell you for some of these, especially down here, you're going to want a calculator. I have my calculator. You can maybe share. I have I have like 3 in here. If you don't have one, you can come grab one of mine. Because especially when you're doing ratios, you're going to need that. Okay. So sometimes you're going to be able to figure them out just from looking at them, and sometimes you might have to try and do the things, okay? If you had to guess, can anybody see what these are doing? Not doubling, but halving. Because isn't 4 times 1/2 2? Okay, watch what happens. I'm going to start with 0.25, okay? I'm going to do my ratios. 0.25 divided by 0.5. So you see that it's 0.5. Then let's do 0.5 divided by 1 to get 0.5. What's 1 divided by 2? 0.5. What's 2 divided by 4? Okay, that's what I mean by ratios. You take a y value and divide by the previous y value. And hopefully you can see, oh yeah, these are being multiplied by 1/2 or 0.5. So, when I divided the y values, I figured out their ratios were the same. What kind of function best models the data? Exponential. And I'm just going to write ratios are the same. Alrighty. Suppose you are studying deer that live in an area. The data in the table was collected by a local conservation organization. It indicates the number of deer estimated to be living in the area over a 5-year period. Determine which kind of function best models the data. So this one's one that, probably you're not going to be able to see without a calculator. So I'm going to just start with one of them. Let's start with exponential. That's easy, and it's going to be really clear right away if it's not, because I'm going to divide and then I'm not going to get the same thing. So I'm going to start with 243. If you have a calculator, let's do the same thing. Let's do 243 divided by 324. I get 0.75. All right. What's 324 divided by 432? It is! Let's just make sure that this is the pattern throughout. Yes. So, what kind of data is this? Good. Okay. So, I'm going to write what I got. I got times 0.75, because when I divided, that's what number I got. And then I'm going to write exponential. Exponential. Okay. Did you guys see how to find exponential now? Okay. I'm going to quick show you this one. This one is also exponential, but I think we're kind of tired of, maybe we're not tired of doing exponential. When you do these ones, you get 0.2. Who's seen that? Okay. So if I want to know, don't write just down the word down. You should either write a sentence or show me some work, like that you know that this is times 0.2 each time. This is exponential. Okay, now just so you believe me that they're not all exponential, let's say we're going merrily along, and alright, 3 divided by 1, yay! 1 divided by negative 1, uh-oh. Uh-oh. Am I getting the same thing? No, this is not exponential then. So, what are the other things I try then?
Linear.
Let's try differences. So, let's subtract. What's 3 minus 1? 2. What's 1 minus a negative 1? Careful, not 1 minus 1. 1, you do 1 minus the table value. So 1 minus a negative 1 is actually 2. Yeah. And then if I did negative 1 minus a negative 3, that's also 2. And this is also 2. These are all going up, not multiplied, by 2. The first differences were the same. What kind is this? This is linear, and 2 is actually going to be the slope of the line. Okay. So watch once again. Let's say I started to divide these, okay? So 19.8 divided by 8.8. Okay, 8.8 divided by 2.2. Nope. This is not exponential. So now what should we do? Let's do differences. 19.8 minus 8.8 is 11. Plus 11. 8.8 minus 2.2 is 6.6. Well, this isn't linear, but what I'm still going to write these down because then I'm going to do the second differences because I'm guessing it's quadratic. What's 2.2 minus 0? 2.2. And 0 minus 2.2 would be negative 2.2. So, can you see that the first differences are not the same? Now let's try second differences. So I'm going to start at 11. 11 minus 6.6. I did 1. 11 minus 6.6. 4.4. 6.6 minus 2.2. 4.4, right? 2.2 minus a negative 2.2. What am I getting? Okay, so these were the first differences. These are the second set of differences. What kind of model or what kind of function best models that data then? If the second differences of y values are the same. Good. Above it says quadratic.